Hello and welcome to all in this video lectures series on 8051 microcontroller. We are discussing hardware interfacing with 8051 microcontroller, and in today's video session we are going to talk one of the most important external hardware device interface with 8051 microcontroller, and that is analog to digital converter, that is an ADC, right? In short, in this video session we are going to talk about the ADC interfacing with 8051 microcontroller. So basically, the ADCs are nothing but analog to digital converters, and these are the most widely used devices for data acquisition. A physical quantity like temperature, pressure, humidity, velocity, which are say available in nature, or I will say as the natural quantities, these quantities are converted into electrical equivalent signal, which is in the form of voltage or a current, using a device, and that is called as a transducer or a sensor. For example, if you want to sense a temperature, we are using a temperature sensor. For pressure sensor. For humidity sensor. For velocity sensor. What basically it's going to do? Simple. Whatever the analog quantities are there, that analog quantities are converted into its equivalent electrical signal. So this is the first task, right? And this equivalent electrical signal is no doubt present in analog format. So simple, sensor is going to convert one form of energy into another, as we know that. And that one form is nothing but what? It may be like temperature, pressure, humidity, or a velocity. In short, the quantity that we want to measure, and that quantity that we are going to measure or we want to measure, right? So that simple converted into its equivalent electrical signal. Okay, and that electrical signal is what? Analog in nature, right? So we need analog to digital converter to translate analog signal to digital numbers. So we are using the microcontroller, okay, so that the microcontroller can easily read it. For example, simple, what is the need of this ADCs in or to interface the ADC to 8051 microcontroller? Let us consider we want to deal with temperature measurement system. I want to design a temperature measurement system. Okay, so what I am supposed to do? Right now consider I am there with one say room. I want to measure the temperature, and whatever this temperature is there, this I want to display on the display unit, right? So no doubt, to sense the temperature I am using sensor. So what the sensor is going to do? The sensor simple going to take the temperature, that is a natural quantity, as input, right? And it is going to convert that into equivalent electrical signal, and that electrical signal is what? As discussed, these are there into analog in nature, right? So here whatever the display unit is there, that display unit is interfaced to 8051 microcontroller, okay, and this 8051 microcontroller is going to understand only digital signals. Directly the analog signal it is not going to process. So what we are going to do? We are going to make use of this analog to digital converter, right? So these analog signals are given to the ADC, and now these analog signals are converted into this digital format, and now this signal is given as what? Simple, the input to 8051 microcontroller. Then as per the requirement, the microcontroller is going to process that input digital data and going to display on the display. So in short, the analog quantities which are present in nature are read with the help of sensors. The sensors are going to generate the equivalent electrical signal, right? So these electrical signals are again there into analog format, and these analog signals, in order to process, right, what we are going to do? We are going to give that to the ADC unit, the most important one, analog to digital converter, so that whatever this electrical analog signals are there, that are get converted into digital format, and these digital signals are easily say processed by any embedded system, and finally it is given to the proper output unit. Because this, in order to display the things on the output device, right, whatever the data that required, that data is given to the 8051 microcontroller, and 8051 microcontroller is going to operate on the TTL logic, transistor logic, which is nothing but what? Requires the analog format. So conversion of analog data into digital is very much important because the microcontroller is going to process only the digital data, and for that purpose we are going to deal with this. So that's why we are going to make use of this analog to digital converter, right? So basically there are two different ICs that we can interface. The first one is a 0804 and the second one is a 080, right? So simple, here I can use either 0804 0804, or as per my requirement I may go with 080, right? Any of this IC I can use as an analog to digital converter, which is going to accept the analog input, and simple, it is going to process the input analog signal and going to produce the digital data, and this digital data is readily given as an input to your 8051 microcontroller, right? So let us discuss this ADC0808 interfacing with 8051 microcontroller. So to better understand this, let us consider this pin configuration of ADC0808. As like 0804 that we had discussed in a previous video session, this pin configuration I took from the Proteus library, because the same we are going to this implementation, the coding and its execution we are going to test in Proteus itself, right? So, so first of all, the IN02, IN7, the input data lines. These are basically called as what? The input channels, right? So this IN02, IN7, total 8 input channels are there with me, right? And at a time, one input channel has been selected depending upon the address lines configuration. Okay, so when we are going to compare this 0808 with that of 0804, right? So in case of 0804, we are there with one single pin, and that pin is called as a V plus VE. Okay, where we are going to give the, or through which we are going to accept the analog signal. However, in case of 0808, we are there with such kind of 8 input channels. Means we can accept the input through these 8 different input channels. Okay. However, only one pin is get activated depending upon the configuration of address lines. So here, whatever they shown, add A, add stands for here the address, right? So address A, address B, and address C. These are the address lines. Okay, these are also an input. Input in the sense what we are going to here from external environment we are going to accept an input. This external, through external environment means what? Through sensor we are going to take the data as a input. Okay, the add A, add B, and add C. These are what? Simple the address lines. So depending upon configuration of these address line, one of the input channel has been selected, and this selection of the address line is also done through where 8051 microcontroller. We are going to give a proper signal, right? So as the 3 bits are there with me, so I am going to select either one from it. For example, if suppose it is A, B, C, right? So if it's 000, the status of address line A, address line B, address line C is 000, then my input channel 0 is selected. Suppose it is 001, input channel 1 is selected, 010, input channel 2 is selected. In this way, when all the bits are 1, I am going to select the input 7, means this input line I am going to select I show, right? So simple, as like that is present in multiplexer, right? We are there with the select lines, and depending upon the address lines, depending upon the select line, out of the many, only one input I am going to select, right? So depending upon the configuration of these bits, okay, I will rewrite it over here. Suppose my bit configuration is say 000, this input channel 0 is selected. If my bit configuration is 100, input channel 1 is selected. If suppose the configuration is 111, right, then this input channel 7 is selected. So in this way, depending upon the configuration of these input channels, right, the address line, a specific input channel has been selected. Now next, ALE stands for what? Address latch enable, and it is used to activate the address lines. Okay, means what? Suppose I am going to accept an input from input channel 1, and I have connected a sensor to in 1, that is input channel 1. Okay, and I want to accept this input inside this ADC. here something like this, and there with this 0808 IC, and here I am using this input 1, right? So when the data is coming from here, right, so first of all we have to select this channel, and in order to select the channel, what I am going to do, as the channel 1 is there, means what, here 010, this is my bit configuration. The address line A is 0, address line B is 1, and address line C is 0, right? So even after configuring this, unless and until I send one this pulse, that is low high to low pulse, means I am going to activate the ALE signal, this channel is not selected. Or in short, to select the input channel is selected by configuring these address lines, and the proper input channel activation is done through this address latch enable signal. Okay, and this signal also we have to send from 8051 microcontroller, right? So here simple, input 0 to input 7, either one of the single input we are going to accept from sensor. Then address line A, B, C, this we are going to give from 8051 microcontroller, and again this ALE. ALE is also given from what? Where 8051 microcontroller. Right. Now the next one here. Okay. This is called as a start. Whatever the pin number 6 which is present here. The start is nothing but what you are, or in some of the data sheet it is also mentioned like SOC, that is what, start of conversion. Okay. Just try to recall the 0804 interfacing. What we did, first the input is given to V in plus, as the single input channel is there, there is no indication of this address line. So when I am going to give an input, right, so simple, this input is accepted by ADC0804, no doubt, but the conversion begins only when we are going to issue this WR bar signal. So what this WR bar is going to indicate, it is going to give a start command to start the conversion, the analog to digital conversion. It is going to begin only when the WR bar signal is issued. In the same way, here the SOC signal is there with me, that is nothing but what, the start of conversion signal, right? So it is used to inform the ADC to start the conversion. So no doubt, first I am going to select a proper input channel, then to activate that channel I am going to configure the address line, I am going to activate the address latch enable signal. So after enabling the address latch enable, no doubt the analog data is accepted by the ADC 080. Now this analog data is went inside this 080, but its conversion from analog to digital begins only when the start of conversion signal is issued by 8051 microcontroller. And this is also what, this is also an active high signal. We have to send one low high to low pulse here. So the moment at which I am going to send this low high to low pulse, whatever the analog data that is received through input channel, the data conversion from analog to digital begins after issuing this SOC signal, right? So simple, first select the channel, accept data, after accepting just start the conversion, right? The next, the most important one is the EOC. EOC stands for end of conversion. Whenever your analog data is completely converted into digital format, this indication is given by 0808 IC through this EOC pin. And this is what? This is basically an output signal. Output signal means what? Here again, SOC, this signal is also given from 8051 microcontroller. But when I am going to talk about this EOC signal, the EOC signal is given by 0808 IC, which indicates that whatever analog quantity that taken as an input is now completely converted into digital format, and it is available on the output data lines, right? And when, okay, as mentioned here, when data conversion is completed, this pin goes blue, right? Suppose at this moment the analog data is with me, right, and up to this moment, right, so say t is equal to t1 to t is equal to t2, between time span t1 to t2 my data conversion is in a process, and still my data is not completely converted into analog format, and at moment t is equal to t2 the analog data is completely converted into digital format, right? So what will happen when the data conversion still in process, the status of EOC pin is 1, and the moment at which this analog data is completely converted into digital format, end of conversion signal is going to change its status from 1 to 0. in this, right? So what we have to do? Simple, we have to wait for this specific signal from 0808. So the moment at which I am going to receive this end of conversion signal from 0808, the next signal that we are going to issue, and that signal is mainly called as what? Output enable signal. So the output enable, this is used to read the data from ADC, right? So whatever the converted data is there, this converted data is present on the output lines, and to read the data from output lines of 0808 inside 8051 microcontroller, we have to send this output enable signal, right? And this is also an active high signal. This OE signal is also given from 8051 microcontroller to ADC0808. And at last out 8 to out 1 to out 8. These are the data lines. When the analog data is accepted from an input channel, that data is fully converted into digital format, and digitally converted data is present on this output links or the output data bus, I can say, right? And to read this data from output data lines, what we have to do? We have to issue this output enable signal. So the moment at which I am going to issue the output enable signal, what will happen? The data which is present on the data line is now read by 8051 microcontroller, right? So these are the steps for 0808 interfacing with 8051 microcontroller. No doubt we have to take into consideration this, that is first the input channel, then address line, then the address latch enable signal, followed with start of conversion, then end of conversion, and at last the data lines, right? Data lines, these are associated with what you are 0808. So no doubt the input signal, this input signal is taken from sensor. So no add such big pin configuration port programming is required here. The address line is configured from 8051 microcontroller. The activation signal is also given from 8051 microcontroller. The start of conversion is also given from 8051 microcontroller. However, this end of conversion is informed by ADC to 8051 microcontroller. Okay, and at last the data lines. The data lines are also, or the data is also given from given from ADC0808 to 8051 microcontroller. So in short, when I am going to deal with a bit configuration here, the pins of 80 port pin of 8051 microcontroller which are connected to address line should be configured as output. Now we are talking from 8051 microcontroller's point of view. Right now we are standing here and we are sending a signal, right? So no doubt I am going to send a signal to address line. So it is a output. Again, address latch enable output, start of conversion output. However, this end of conversion I am going to receive from ADC0808. So this should be what? Input, right? So here I will write here the blue color represents what my output. This is output, and my green color, this bluish color, this configuration represents input. So these two pins are input. So in this way we have to do what? The whole program. Now next, what is that? Select the proper analog channel. So this analog channel is done by configuring this what? Address lines. Then activate ALE, address latch enable. I am going to select the input channel by configuring the address line, and activation of this is done by sending the high to low pulse, that is low high to low pulse on the ALE pin, right? Then next, activate start of conversion. So activate the channel, then give the command to begin the conversion and wait for EOC, that is for what? End of conversion. And no doubt by default its status is high, and the moment at which conversion is done, we are going to move to the EOC, right? And once the high to low transition is seen on this EOC pin, okay, read from the EOC pin, send this output enable, okay, OE, okay, this is also what the output from 8051 microcontroller, and read the data from 8051 microcontroller, and then finally clear this output enable, right? So these are the simple steps. So when I am going to pay attention here, okay, so the things are clear. How we are going to proceed here? First, configure address line. So first of all, just go for address lines. Once I configure the address line, then activate this address lines, and the activation is done through by whom? Your ALE, that is what? Address latch enable. After activation, give the command to start the conversion. Start conversion, and that is done by whom? The SOC, that is start of conversion. Okay. Then once we send the start of conversion, wait for end of conversion, and this is done by which pin? EOC. And once it is done, then enable read option, means to read the data. So output enable and just copy the data. And once we copied the data, then go with the disabling the data here, right? Again the OE pin, and here the output lines. So these are the pins sequentially we have to utilize for the programming of 080. So here I am there with, this is my timing diagram. So let us first find out the sequence of programming. So first of all, I am going, so this is the first I am going to configure, that is what the address line. So this is for what the better understanding how exactly the 0808 works, right? So first we are going to configure, and from programming point of view, first of all I am going to configure the address line. Once I am going to configure the address line, go with the address latch enable, that is with what? ALE. Once I am going to activate the address line, give this, that is what? Start of conversion. SC stands for start of conversion. Okay. Once the start of conversion signal is issued, wait for this end of conversion. And whenever the end of conversion high to low transition is done, just give this RD bar signal, and after giving the RD bar signal, at last take the data from this D0 to D7 pins. Right. So in this way we are going to do the programming. Now let us understand this. So what we are going to do the first of all, I am going to enable configure the address line. Okay. So the moment at which I am going to enable this ALE, whatever the address line configuration is there, depending upon this configuration of address line, one of the input channel of 0808 has been selected. Now the analog data is taken as a input. Input where? Input in where? In this 0808 IC, right? After ALE, then I am going to give the start of conversion, one low high to low pulse here. The ALE is also given as low high to low, right? So the end of conversion, start of conversion. So the moment at which I am going to give the start of conversion, this 0808 begins the data conversion. Right? So we have to wait here, right? So I can say from this specific clock up to say this clock, the data conversion is in process. And the moment at which, right? So here it is initially high. The moment at which the data conversion is done, say this is my clock number 1, 2, 3, 4, 5, 6, 7. Okay, at the 7th clock, suppose my data conversion, I think it is 7, 1, 2, 3, 4, 5, 6. Okay, at the halfway of 7th clock, I will say, right? So at the 7th clock, when the data conversion is completed, what will happen? The EOC is going to change its status from high to low. And the moment at which the status is changed from high to low, to read the data, I am going to send this low high to low. That means I am going to send this output enable signal. Right? So once I am going to issue the output enable signal, then I am going to read a data on data lines of 8051 microcontroller from 080. So in this way, we are going to perform a simple interfacing of ADC0808 with 8051 microcontroller. So let us see the simple program and its execution in Proteus. So before that, this is the interfacing diagram which is there with us. So to better understand what I did, I used the same labels here. So let us first understand the label. Over here, A0 is nothing but address line A, A1 address line B, A2 address line C. Then SOC start of conversion, EOC end of conversion, then output enable and the ALE address latch enable. Okay, and here the out pins are connected to 8051 microcontroller. So then I am going to talk here, right? So the address line A, address line B, address line C, these are connected to P2.0, this is to P2.1 and this is to P2.2. And these are configured as what, or titled as A0, A1 and A2. Okay, then next SOC, the start of conversion. This pin is connected, or we are going to utilize the P2.3. Then for end of conversion, P2.4, then output enable P2.5, and at last for address latch enable this P2.6. Right? So in this way this pin configuration is done, and whatever the data, that digital data that is coming from ADC0808, which is from out 1 to out 8, is accepted from port P3. So this is my configuration. So as usual, this this port is going to represent the sensor. Whenever the resistance of this port is varied, the input that given to channel number 1 is going to change. Consider that channel number 1, in the sense I am going to make use of this IN0. Consider we are going to accept, or the sensor is connected to the 0 channel, the first channel of 080. Here I am going to connect the 1 kHz clock externally, and whatever the analog data that converted by ADC0808 present in digital format on output line is read by this port P3, and this data I am going to forward as it is to port P1, so that I can read that on this LEDs by changing the rate of its beam. Okay. So this is the scenario, and now for this we are going to see the simple program in Kyle as well as its implementation in Proteus. Consider this program. So as said, A0 represents address line A, A1 address line B, and A2 address line C. Okay. So these address lines of 0808 are connected to P2.0, P2.1 and P2.2. Start of conversion connected to P2.3, end of conversion to P2.4, and output enable to P2.5, and at last ALE to P2.6. Okay. So here the port P3, to which we are going to take a data from simple this ADC0808. So that's why port P3 is configured as an input. Port P1, to which we have connected the LEDs to analyze the digital data, is configured as a output. So initially, as the ALE output enable, end of conversion, these are the output lines. We made these pins as a 0, and then the end of conversion, which should work as an input, right? So that pin is connected or configured as a input. Okay. So here the step by step. The first step is what? Simple, go with configuring the address lines. So what I did, simple, A0 is equal to 0, A1 is equal to 0, A2 is equal to 0. So this basically represents what? This specific, say the lines, the line number 14 to line number 19 represents the port configuration. That is the step number 1, right? So the step number 2, what is the step number 2? Configure the address lines. Okay. So A0 is equal to 0, A1 is 0, A2 is 0. So what will happen because of this? Because of these 3 lines which are equal to 0, 0, 0, right? So the channel 0 of 0808 ADC has been selected. Then activate this line and simultaneously give the start of conversion signal. So I am going to make ALE1 SOC1, then going to call some delay, right? So here when this initially the ALE signal is 0, right? So it is there at the low level. After that I am going to make it high, then it is going to make what? The low to high signal, and then some delay here. So it remains for high, and then AL is equal to 0, means low, high to low pulse is given in order to activate this line. And then simultaneously I am going to first send the ALE, and immediately I am dealing with what? The SOC, right? So here the input channel is activated and the start of conversion signal is given. Then wait for the end of conversion, because here when I am going to send the data, means I am going to receive a data from sensor. That data is there into analog format, or the quantity is there into analog format, and the moment at which this SOC is going to get changed to 0, means low, high to low pulse given on the start of conversion, what will happen? The ADC begins to start the analog data quantity into digital conversion, right? So till then the EOC is still as a 1, and the moment at which it is going to change it to 0, right? What will happen? At that moment the analog data is completely converted into digital format, and then we are going to send. This is for the precautionary purpose, this instruction we have kept here, right? And what will happen because of that? The OE is equal to 1, means activate the read enable signal, just read the data from this port P3, and whatever the data that we read, simple, just forward it on port P1. So in this way, by following the given steps, we are going to write an instructions, and I have performed the ADC0808 interfacing with 8051 microcontroller. So let us see its implementation in progress. So here, as said, address lines, that is A0, A1, A2. These are nothing but what? Address line A, address line B, address line C connected to P2.0, P2.1 and P2.3. Start of conversion connected to P2.012. These are for address lines. Start of conversion is to P2.3. End of conversion is to P2.4 and output enable is to P2.2, and at last this address latch enable. And here whatever these labels are there, these labels are get equated to this specific. This is a labeling concept, that simple we are using. Instead of drawing the lines here, simple I am going to configure this pin and providing the proper labels here, right? So once here, just check out the same right now. And here the channel 1 is nothing but this, the input channel 0 that we have selected. So initially the port is at its 0% position, means not a single voltage level is given as an input. Now when I am going to goes on increasing in response to that, I will say my input is now there into the analog in nature, and that input is converted into digital power. So the way in which I am changing it, in response to that, the LED are get ultimately turned on and off. So this represents what your digital data, right? So simple. If this digital data we convert into what we call that into ASCII equivalent ASCII format and given to the LCD, that later on we are going to discuss. Simple, I will give the original readings from the whatever the input levels are, and at maximum level I am going to get here. 93%, 94, 95, 96 and plus 90, and for 100. For 100% all the LEDs are 100, means input given is a plus 5 volt and corresponding to plus 5 volt my output is what? 255. And corresponding to 255 all the LEDs are 0. Okay. So here when I am randomly changing the position of a port, the voltage levels are goes on changing, and in response to that the digitally converted data bits are also goes on changing. So in this way, we can interface the 0808 with 8051 microcontroller and simultaneously test that in this Proteus Simulation software.